Thank you.
Okay, today we are looking at measures of central tendency. You have already studied mean, median, and mode. We're looking at a new type of mean. It is a weighted average, not just an average, and it's referred to in mathematics as expected value. Expected value is the sum of all the outcomes times their probabilities. Here's an example of a World Series game. To win the World Series, you have to win at least 4 games. So it'll either go to 4, 5, 6, or 7 games. Here's the individual probabilities of those. So the expected value is the outcome times its probability, plus the outcome times its probability, plus the outcome times its probability, plus the outcome times its probability. When we find the sum of all these, we get 5.85. Now, 5.85 is actually not a possible outcome, but on average, after a long time, the average would be 5.85. Then we did an example involving traffic lights. The number of traffic lights you'd be stopped at times their probabilities, so that's all we do. Multiply, add, and we get 2.25. So the expected value for the number of red lights you'd be stopped at was 2.25, which once again is not an actual possibility, but is the expected value over the long term. The next example is regarding a deck of cards. If you draw a red card, you win nothing. So red, nothing. If you get a spade, you win $5. Spade, 5. Any club gets you 10 and 20 more for the ace of clubs. So a club that's not an ace, 10. The ace of clubs, 30. Now, the probability for red, well, half the deck is red. What's the probability for spade, class? 1/4. Because a fourth of the deck are spades. Now, how many clubs are not aces?
12.
12 out of how many cards?
52.
52. And then how many ace of clubs are there?
1 out of 52.
1 out of 52. Okay, class, I'd like you to find the sum of all of the possible outcomes times their individual probabilities and find the expected value. So this is our formula for expected value.
13.
8, here's 10.
Okay, I'd really like you to use your graphing ones.
Oh, graphing.
Why would fantastic use the difference?
Thank you.
I think it was. I thought it was really good as well.
I got it.
I got it. Don't tell me
Good
yet.
to know.
4.1.
That's what I got too.
3, 4,
All right, Jake.
Okay, so what we're determining here is the expected value of our winnings if we were to participate in this game. Over and over and over again, in the long term, what could we expect to win?
$4.13.
$4.13.
Studying $4.
Okay, now this would change slightly if you had to pay to play. Okay? If you had to pay to play, then what we would do is, let's say it cost you $1 to play.
So it'd be -1.
Well, this would now turn into -1. This would turn into 4. This would turn into 9, and this would be 29. So if we had to pay to play, it does change our expected value. It would decrease it. Okay.
Oh man.
All right, so we looked at measures of central tendency. Now let's talk about measures of central tendency is where does the data center? Where does the center of the data tend to be? Central tendency. So we looked at mean, we looked at median, we looked at mode, and in addition to mean, we looked at the weighted average, which was expected value. Now we're going to look at measures of variation. How does the data vary? Now range, we started studying in elementary school. How do we define range?
The biggest minus
Highest
the
minus.
smallest.
Big minus small, high minus low. I like it. Okay. IQR. What does IQR stand for? Interquartile range.
Oh, that one's hard.
And so
Liar.
this is just Q3 minus Q1. Now, remember your 5-number summary from last year. The 5-number summary can be found by doing 1 variable statistics on your calculator. I know my 10th graders did this. My 9th graders
Probably
did not say they did it. So to do what we'll practice it today though, so everybody will be good. So 1 variable stats gives you the min, the Q1, the median, the Q3, and the max. So the IQR is just that Q3, which is the median of the upper quartile, the upper half of the data, and the Q1, which is the median of the lower half of the data. So IQR is Q3 minus Q1. Now, range takes in that largest minus the smallest. IQR does the median of the upper half minus the median of the lower half. Which one is less affected by outliers? Extremely high or extremely low values?
Extremely low
IQR.
values.
So the range is affected. The IQR is not so much. Now, here are new ones. Variance, which is the square of the standard deviation, and standard deviation. This lowercase sigma, the Greek letter sigma, represents standard deviation. Now, we talked about this at the intro to the class. Standard deviation is the most common and most useful measure of variation. You hear a lot about this. If you read any evidence where statistics have been taken, it'll be in terms of how many standard deviations from the mean. Now, lower values indicate that the data is more centered around X bar. What does X bar represent for us? The mean, the average. Good. So the smaller your standard deviation, the closer to the average most of your data lies. All right. Now, determining the standard deviation is something new.
Interesting.
The variance, which is the square of the standard deviation, is this. What does this symbol mean again?
Sigma.
Sigma.
It's
The
a
capital.
capital sigma, and it means sum.
Oh, so close.
Find the sum of the squares of the differences divided by how many pieces of data you have. Now, for standard deviation, all we're doing is taking the square root of that. So standard deviation is just the square root of the sum of the difference of all the squares divided by n.
True.
Okay, so let's go through it slowly. This is the exact data that's on your sheet. All right? And this data, it says, represents the amount of a substance found in a patient's blood at consecutive doctor's visits, and it's measured in milligrams. So here is all our data. Step 1 in finding standard deviation is to find the mean. Okay? I would like you to take your calculator, go into stats, enter this data into L1, and then you're going to calculate the one variable statistics. And I want you to find the average. Yes, sir.
10.
You got it.
What?
He's fast.
Fast.
Our boy
So you click
Pat.
I got it.
Our
Variable
boy
stat.
Pat.
M got it too.
Cool.
10.
Oh yeah.
10.
Awesome.
Do something, man.
10.
Deserves a
10.
prize.
Wait, you click variable. What do you mean by
Okay,
one?
stat. You're doing one variable stats. You're calculating the one variable statistics for L1.
I got 9.
Wait. That's not right.
All right. Open up L1 and make sure you entered every piece of data.
I know.
I imagine if yours is low, you have forgotten a larger piece of data.
10.
Or maybe you divided by a number that was too large.
It didn't.
Okay.
There we go. I got 9.
I totally do that.
14 plus 13.
I like didn't read.
Okay. All right. So now we're going to find the sum
Stupid mistake.
of each piece of data minus the mean squared. All right, so what is 14 minus 10? 4 squared is 16. Plus 13 minus 10 is 3, squared is 9. 6 minus 10 is 6, squared is 36. 9 minus 10 is negative 1, but negative 1 squared is 1. 3 minus 10 is negative 7, but negative 7 squared is 49. 11, wait, no, 7. 7 minus 10 is negative 3, squared is 9. Then 1 squared, 2 squared, 1 squared, 6 squared,
36.
36.
So what-
So
which
we
one does it
add
say?
up all of those, and then we divide by n. And how many pieces of data were there?
10.
10.
True.
So it's like 10.
Okay, so what do we get for this?
16 plus 9 plus 36.
We get
plus
16
1 plus
point
4
what?
plus
16.2.
16.2.
So that tells me, this gives me the variance. The variance. It is 16.2.
Squared.
Okay? Now the standard deviation is the square root of the variance. So the standard deviation is approximately 4.02. Now, I would like you to look at your calculators under those one variable stats. Do you see that when you did one variable stats, it also found the variance, and it also found the standard deviation? Yes, Patrick?
Wait,
I was just
mine
going to
didn't
say
show
how it has
standard
the standard
deviation.
deviation there as one and all.
Good, good. It does. Now, we actually have two different types of standard deviation. We have standard deviation for the entire population, which is what we're looking at. And there's another type of standard deviation if you just have a sample. Okay? If you just have a sample, and that's the one that's actually most often used because you're not going to usually look at it, the entire data set. So we'll just look at part of it. And so in that case, you would, instead of dividing by n, you would divide by n minus 1. So those of you that are going to take AP Stat are really going to delve into the differences there.
Yes.
Yeah, and it's some neat stuff you can look at.
So what is it?
And it has some different symbols, X bar and mu, and anyway. Okay. So, if we look at this, what this means is, on average, the patient's blood contained 10 milligrams of the substance, and the average standard deviation from that 10 milligrams was 4.02 milligrams. Now, later on this week, we're going to talk about what that standard deviation means, how we can interpret it, and we are going to make predictions like 68% of the data would fall within one plus or minus one standard deviation. Yeah, no, it's not. It's good stuff. You're gonna like it. Okay. Now, the next part, SOX, is our acronym that helps us remember the different ways to describe our data sets. Now, shape. We talked about this last year, didn't we? When we looked at statistics. We have the bell-shaped, which we call symmetric. Skewed right if the tail of the data goes to the right. Skewed left if the tail of the data goes to the left. Uniform if it's approximately uniform. Bimodal is when it has two peaks, right?
Wait, I'm confused on what's the difference between bell and uniform if they're both symmetric.
Oh my goodness.
No.
Bell looks like a bell,
You know
like
what the bell curve
the
is?
Liberty Bell. Looks like a bell.
Uniform is just like a flat line, pretty much.
Uniform is straight across. Okay? Center. When we talk about the center, we're really focusing on two different statistics here. Mean works well for non-skewed data without outliers. If we have the outliers, it's going to pull the mean towards that tail or the outlier of the data. Median is our best choice when there are outliers. It's best when we do have that skewness or the outliers exist because it is resistant to being changed by the skewness and the outliers. Now, spread. How far apart is the data spread? That's our standard deviation. Works best for non-skewed data. And then IQR, we talked about it's not affected as much by outliers. It's best when there is skewness with the data or outliers do exist. Now, we defined outliers last year using this formula. We defined an outlier as any piece of data that was less than Q1 minus 1.5 IQR or greater than Q3 plus 1.5 IQR. Now this year, we're going to add to that definition one that's actually even better, is if it is beyond plus or minus 3 standard deviations from the mean. So that's what this means, plus or minus 3 standard deviations from the mean. So if it's greater than positive 3 standard deviations from the mean or less than negative 3 standard deviations from the mean. Okay. And then the last thing, when we're comparing our distributions, we can visualize those in many different forms. Box and whisker we studied last year, where we used our 5-number summary. The max and min were dots. The Q1, the median, and Q3 were represented by lines. We know that this divides our data in 25%, 25%, 25%, 25%. So box and whisker is a nice visualization of that. Easy for me to say. Dot plots look like dots. Do you remember the dot plots? I think we spent part of one day making dots. Stem and leaf. Stem and leaf you did in middle school. It's where you would have like the tens digit here, and then maybe
I did not
there were,
know those.
and then
This was a his thing.
okay. So they would break it up, and you could look at the leaf part to tell how many things fell within that. Histograms. We did histograms last year. Histograms were used for continuous data. So it was anything that we could measure, measurable data. And we had ranges. And with a histogram, it kind of looks like a bar graph. But with a bar graph, we have like categories. Like if we went out into the parking lot and we counted the number of red cars and the number of blue cars, the number of white cars and the number of green cars, we could create a bar graph. And along the bottom, we have our different categories. Red, blue, green.
Or we could.
But we could also do a histogram with something that's measurable, like the odometer reading. So then we could take the same inventory of cars, automobiles, and create a histogram that shows the different mileages on all the cars. And in that case, we'd have it in ranges, and it would be connected. Does that make sense? Okay. So your homework is actually what's listed on the calendar for Monday. Okay? So this is tonight's homework. This is Friday's homework. Okay? And
Rolling down the river.
you have the rest of class, which is about 8 minutes. You can get a nice start on that assignment.
13 minutes.
No, 13 minutes. You're right. It's been so long since we've been on a regular schedule.